Hello everyone, welcome back. This is a Calculus 3. So in this video, we're going to talk about 2.5, equation of lines and planes in space. So I'm going to show you a couple equations to describe the line in three-dimensional space. And then we are going to talk about more information, how to find out the equation of line, equation of the plane, and distance. So we have a lot of information today. So let's step-by-step work, okay? So let me recall what does it mean for two vectors to be parallel line. So if you guys remember, you have two vectors are parallel. That means that they have a scalar that could make one of the vector be stretched or strength. So for example, I have a u vector 2, 3, 4, and I have another vector v, and let's say it is a 4, 6, 8. So you can multiply 2 from u to v, so 2 times u vector. In other words, 2 is a scalar, so 2u equal to v. So if you can find out the form, the scalar, we know that it is going to be parallel line. U and v vector will be parallel line because u vector is 2 times longer than v vector. So you can find out the scalar, and then if it is a positive, they are going to have the same direction and it's going to be extended, stretch. If you have a negative number, they're going to be the opposite direction, and depending on the size of k, it could be stretch or shrink down. So in general, if I have another vector, let's say u equal to cv, if c is greater than 1, it is going to be stretch. If c is between 0 and 1, it is a shrink. If c is a negative, you're going to opposite direction. So we have 3 scenario, to define the parallel line, right? So the definition of the parallel line between two vectors, we talked about it. Two vectors, which is non-zero vector u and v, are parallel line if you can find out the scalar k, okay? So this information will be important when we are going to find out the line or the another vectors in three-dimensional space. So let's take a look at more and more, okay? So this is a recall, we talked about it. So let me introduce more information. How to find out. So I have a u vector, v vector, let's say they are parallel line. Can I find out that equation, right? I want to know that equation. We know that this is a vector, but also it is a line, so we can maybe find out the equation of this vector. So that's what we are going to do, right? Find the equation of the line. So the title exactly, we are going to find out the equation of line, because if there's a parallel line, maybe there are some way you can find out the equation by finding maybe some same slope, or is there any commonality between two parallel lines? So let's take a look at it, okay? So that was a recall. So here we're gonna more talk about this. So here we go. I'm going to introduce 3 important equations. So let's step by step. Let L, so I have a line L, be that's in space and passing through the point P here. So P is exactly located where x is 0, y is 0, z is 0. So this is assumption. So let's say we have a point P, and there is another vector v, and then it is the v vector is a, b, c. So as you see that P and Q, they are point, right? This is a point. V is written by vector, right? So this is a vector, and then P, Q are points. So you see the difference between vector and point. Vector include the direction and magnitude. So this is the component, A, B, C are component. And P is located at point x0, y0, z0. So let's say, you have this situation, the line that is passing through the PQ, it is a parallel line, the vector V, okay? So if that is true, I can set it up this equation. PQ, this is the line, right? If this is a parallel line V vector, right? There must be a scalar, let's say T. This is a scalar. And then PQ line and vector V are going to be the parallel line. So we can set up this equation. Am I correct? So from here, let's step-by-step work. Can I find out the PQ? So we can find out the line PQ as a vector. So if you remember, now PQ as a vector, you can subtract, the between two, information. So PX, we have X minus X0, Y minus Y0, Z minus Z0. This is a vector PQ, right? And then we just said that this is going to be parallel line to the vector V. And then the vector V, it is given A, B, C. So far, so good. And then because of this equation, I'm going to highlight it. Now there is a scalar exist. So now I can say PQ is X minus X0, Y minus Y0, Z minus Z0. This vector is equal to T times A, B, C, V vector. So far, so good. I'm not creating any fancy work. I'm literally following the logical thinking. So what does it mean? Now I can say, I can rewrite down the left form. So the X minus X0, Y minus Y0, Z minus Z0, I can break them into X comma Y, Z, minus X0, Y0, Z0. They're the same thing anyway. Must be equal to T, A, B, C. Mathematically, we can solve it. And then now let's solve for X, Y, Z. So X, Y, Z is equal to, so equation, I'm going to move this one to the other side. So X0, Y0, Z0 plus T times A, B, C. So we call, this is like a linear equation, Y equal to MX plus B. Like you can consider T like M. So in this vector system, we call this is R equal to, because it's too long, and then we are condensed R0. This is a 0 plus T V. We call this equation number 1. We call this is a vector equation of a line. Okay, so I'm introducing one equation. I'm going to highlight it. R equal to R0 plus TV. That's a vector equation of a line. Okay, so let me keep going. Let me keep going. So from this observation, we are going to find out another equation to describe the equation of line. So we also know, we found out X minus X0, Y minus Y0, Z minus Z0. We know that this is a T, A, B, C. In other words, this copy paste is the same as, I can use a distributive property, AT, BT, CT. So what does it mean? Now I can say this first position is the same as AT. So from here, we can say X minus X0 equal to AT. B minus Y0 is a BT. My bad, not the B, Y, right? Y minus Y0 equal to BT. Z minus Z equal to CT. So in this equation, we can also solve for X, Y, Z. Here, we can also solve for what the X, Y, Z. So the first equation gives us X equal to X0, TA, or AT, doesn't matter, the order. And then Y is going to be Y0, BT, Z equal to Z0 plus CT. So we have another equation solved for XYZ, right? So we also solve for XYZ, which is this. and then I converted that in terms of the r equal to r0 plus tb. We call that as a vector equation. We call this one, we call this equation, we found out, so solving for x, y, z, parametric equation of a line. So they're indicating the same information, just we have a different form and we have a just different name, but they're indicating the same thing, equation of a line, okay? We can do one more thing. So I'm gonna keep going. And then next one, we also know, or we can solve the equation in terms of t. So from here, number 2, I'm going to bring that equation. Copy, paste. Then I'm going to get rid of it. So from here, let's solve for t. So in this time, we are going to solve for t. So let's see what's happening. T equal to x minus x0 divided by a. T equal to y0, y minus y0 divided by b. T equal to, we can find out z minus z0 over c. So in this time, we have the same information from here. I'm going to make a little bit smaller. So what does it mean? X minus x0 over a is the same as y minus y0 over b, same as z. They're all t. So we call this is number 3, systematic equation of a line. So we use those 3 equations to indicate the equation of a line between the vector that are parallel line. Okay. So from this observation, mathematicians, they discovered 3 important equations. One is a vector equation. Second is a parametric equation of a line. And the last one is a symmetric equation of a line. Okay. So I'm gonna just organize this information. Okay. So this equation, were found from the observation between 2 parallel lines. And then we call each this form just equation of a line between 2 vectors. Okay, so let me go down slowly. So we found out 3 equation, exactly textbook, show you the same thing. So if a line, so this is the background, we just talked about it. A line in 3-dimensional space is determined by point x0, y0, z0 on a line. And there's a vector a, b, c. And let's say they're parallel line. We just talked about it. And then the vector v, we can also call direction vector. From this observation, we just found out 3 important equation: parametric equation, vector equation, symmetric equation. So the format is, this is the parametric equation we talked about. We solve for x, y, z. And then the vector equation is a solve, we convert it to the r. So if you go up, this is a vector equation. So that is r0, that is t times v. So therefore, we found out this information. And the last one, we found out the symmetric equation. So I will show you the example where and how you're going to use those 3 important equations when you find out 2 parallel line vector. Okay, so based on this equation, let's take a look at the couple example. Let me go down slowly. Okay, so in this question, they want you to find out the parametric and symmetric equation of a line. They're passing through these 2 points. Okay, so one is a 1, 4, -2. Another one is a -3, 5, 0. So these are 2 vector, right? And then I want to find out the equation that are parallel line. I'm sorry, they're parametric and symmetric equations. So let's do step by step. Because a point, let's say let P 1, 4, -2 and Q is a negative 3, 5. They are B, the points. So to convert it to the vector, we're going to find out the PQ vector, right? So this is going to be the vector. You're going to subtract the difference. So it's going to be now negative 3 minus 1, comma, 5 minus 4, comma, 0 minus 2. So you will get negative 4, 1, 2. So this is going to be the vector. This is the vector component that are passing through those 2 points P and Q, right? So this is the vector that is passing through the 2 points P and Q, correct? Now I want to find out that equation. So we found out PQ. So we found out P points and Q point. As a vector, we found out negative 4, 1, 2. I want to find out the name of this equation, right? So we need to find out 2 forms. One is a parametric, another one is a symmetric. So we can complete so we can find the first one, parametric equation, okay, by using one of the given point. So let me minimize this. By using, one of the given points. So we know the parametric equation, if you go up, x equal to x0 at, y is y0 plus bt, and z equal to z0 plus ct. So let's plugging in. Now your PQ, this is going to be your A, B, C, right? So this is a component of the vector. So now you can convert it to x is what? X is 0. So one of them are going to be x is 0. So if you go up. So these are the vector, these are the points on the the line. So x is 0, y 0, z 0. These are points. So you can set it up. I'm gonna highlight it. X is 0, y 0, z 0. These are one of the points. So if you're plugging in, I'm gonna use a 1 for negative 2. So 1 plus a is negative 4t, and y equal to 4, right? So 4 plus t, and z equal to 2 minus 2t. So this is your answer as a parametric equation form. Okay, so if you remember, these are going to be x0, y0, z0. You can use it either one, doesn't matter. So this is the point, and we found out the vector ABC. So you can find out that, and also I can find out the symmetric equation. So complete the symmetric equation according to the formula. What is that? T equal to, if you go up, x0 minus x minus x0 over a, and then it is the same as y minus y0 over v, z minus z0 over c. So therefore x0 a, we know x minus x0 minus 1 divided by a, negative 4, equal to y minus y0 minus 4 divided by 1, and then the last one, z minus negative 2, it's going to be positive 2 over c2. So this is your symmetric equation. So they're indicating the line, the equation of this line. Does it make sense? So that's how you're finding the equation of line as a parametric form or symmetric form, by using the given information. So that's why I want to emphasize on those are 3 equation format is going to be used a lot. Okay, so we're going to keep practicing more and more example based on this. So let's take a look at example 2. I hope this is going to be okay. I Whenever you feel like, oh, I have a question, so you feel you're feel free to post into our chapter discussion, or you can always email me, right? And also we have an optional meeting time. You can join and ask a question whenever you have question. All right, example 2. So let's keep going. Find that in this time, we're gonna find out the vector equation form. So let me just change the color, vector equation form and symmetric equation form for the line passing through the point, in this time -2, 4, 5, and there's a parallel line vector v, 3, -1. So you can see the situation. There's a vector v, +3, -1, 6, and there is another line, and this is the line, and then there's a point -2, 4, 5, and they're parallel line. I want to find out the equation of this line, right? To describe as a vector or symmetric equation form. So let's just write down whatever we have here. So we know this is the point. So this is the point. So let's say let P equal to, and then just I have a typo. If you have a point, it's going to be open parenthesis. If you have a vector, it's going to be like a different format of the parenthesis. So this one should be open. So this is the point. So we have a point -2, 4, 5. So this is actually x0, y0, z0. So this is the point. Okay. And then we have a vector, which is a 3, -1, and 6. And then in the equation, they are ABC, right? So we can simply find out the vector equation. The vector equation will be, if you remember RT, go up and check. x0 plus AT, y0 plus BT, and z0 plus CT. Therefore, we can summarize it. x0, -2 plus AT, 3t, and we have a 4 minus t, and then 5 plus 6t. So they are the vector equation form. And now the last one, symmetric equation form. We know the equation. Let me just copy that, right? Copy, paste here. So we know this is the vector equation. So therefore, we can rewrite it x minus x0 plus 2 over 3 equal to y minus 4 over -1 equal to z minus 5 over 6. This is a symmetric equation. So now I want to really find out other points. So we have only one point is a given. So we are not able to find out the vector of this line because we have only one point. So to find other, so there are infinite points actually on this line. I want to find out more points. To find other points on the line, what do you want to do? Right? Choose one of the equation and just choose one of the equation. For example, if I choose a symmetric equation, if t equal to 1, this is t. If t equal to 1, the points plugging in 1 plus 2 over 3, 1 minus 4 over -1, 1 minus 5 over 6, right? So that it is going to be 3 divided by 3, 1, -4, -3 divided by -3, +3, -5, -4 over 6 is -2 over 3. So you can find out this point on this line, correct? Or if t equal to, you can find out so many, -1, you can find out other points. So because there are infinite points on this line, this is one of them. This is one of them. This is one of them. So you can find out other points on the line as long as you know either symmetric or vector equation. Okay, so check that information. Okay, all right, so that's what it is. Okay, and then let me go down slowly. One more example. Let's go. All right, so we are keep using 3 equation we just found out. So number 3, find the parametric, okay, parametric and symmetric equation. Okay, same question. They're passing through the points A and B. So you can find out the vector AB. And then now they're looking for the intersect with the XY plane. So step by step, so we can find out AB vector. So it is going to be 5 minus 1, negative 2 minus 3, 8 minus 2. So it is going to be 4 plus 1, and we have a 6. So this is your ABC. This is the vector. So we have A point, B point, and then as a vector, we found out, which is 4, 1, 6. So by using this information, we can find out the parametric and symmetric equation because we have ABC, and then one of the points are x0, y0, z0, right? So if you say this is x0, y0, z0 point, so now parametric equation, that is going to be x, right? X equal to x0, right? Plus AT. Y is y0 plus BT. Z equal to Z0 CT. So X will be what? 1. You can choose either one. So 1 plus 4T, Y equal to negative 3 plus T. Z equal to Z0, 2 plus 6T. So this is your parametric equation. And we can find out symmetric equation. So that would be T equal to, we know X minus X0, 1 over A. That is equal to Y plus 3 over 1. Z minus 2 over 6. So this is the symmetric equation. Now, so this is the equation of the line. And then they are actually intersect XY plane. And then I want to know where, that is happening. So to find, I'm going to make a little bit smaller. So to find where line cross, right, XY plane, and then we know the characteristic of the XY plane, it is z equal to 0, right? So therefore, I'm going to write to find out where the line XY plane. Therefore, we're going to just use z equal to 0. So we're going to use that one. So from there, so now you can use a parametric equation. So that is going to be x equal to 1 plus the 4 times the 0. My bad. This is not correct because we know z equal to 0. So why am I plugging into not that one? So we are going to z equal to 0. So therefore, from here, 0 equal to 2 plus 60. So we can solve for t. So minus 2, 60. So t will be negative 1 over 3. So when t equal to negative 1 over 3, right? This equation will cross XY plane. I want to find out specific XYZ point. So to find out the point, so this is a t equation. So when x is equal to, so to find out the XYZ, so x, you can plugging in XYZ equation. So now what are you guys going to do? We know t equal to that. So we're going to keep using parametric equation because that's where you find out the t. So x equal to 1 plus 4 times negative 1 over 3. Y, negative 3 plus, actually minus 1 over t. Z equal to 2 plus 6 times negative 1 over 3. So you're going to solve for x, y, z, correct? So then x, y, z, it is going to be negative 1 over 3, negative 10 over 3. I solved them. And then 0, So this is where they intersect with the XY plane. Okay, so that's the exact point on that line. Okay, so think about it. Okay, a little bit, back and forth work, but the calculation part is not that complicated. So you can think about that idea. Okay. All right, so are you guys okay with that so far? So let's take a look at one more example like this. Okay. Okay, so far so good. All right. So I just want to go back to example 2. Hold up there. I think I made a little bit of mistake. So here we are looking for the points on the line. So we found out the vector equation and symmetric equation. So if t equal to 1, we are not going to use the symmetric equation because there's no t. So I'm going to just go back. Sorry about that. So that was a little typo. So a little bit of modification. So if you go back to this one, if t equal to 1, we are going to use the vector equation to find out the x, y, z, right? So therefore, negative 2 times 3 times 1, that is going to be 1. And then 4 minus 1, it is a 3. And then last one, 5 plus 6 times 1 is 11. So when t equal to 11, the point is going to be 1, 3, 11. So that's where you can find out here. And then you can find out infinite number when t equal to negative 1, t equal to 5. So I plugging in here because it was wrong when I did at the beginning, because this is x, y, z, there's no t. So to find out other points, so when t equal to 1, you can use the vector equation. So just check it out. So example 1, 2, 3. We practice a similar work over and over again. Find out the parametric, vector, or symmetric equation, with the given information. So check it out. We are using all the characteristic of the vector. Okay, one more example 4. Here we go. So in this example, okay, show that there are points. We have a 4-point A, B, C, D, and then A, B points. So the AB line, basically, A, B. The line AB is a perpendicular to another line. Okay, perpendicular means there's a C and D. They're going to create the 90 degree. So we just want to prove that whether they're really perpendicular relationship or not. So we know perpendicular characteristic. So if two vectors multiply each other equal to 0, then we can say it is an orthogonal relationship. So we know there are two vectors. So the points are given. So you can convert it to the vector. So vector v1, I will say v equal to the vector AB. So you can find out 1 minus 0, negative 1 minus 1, 6 minus 1, 1, negative 2, 5. So this is a vector v that is passing through the point A and B. And then this one we can also call a direction vector for line passing through A and B. Same thing, we can find out the second vector passing through C and D. That is going to be negative 1 minus negative 4, 6 minus 2, 2 minus 1. So plus negative, negative change to positive 3, 4, 1. So this is another direction vector for line passing through C and D. So therefore, let's prove it. V times W is really 0. So we're going to do V times W, which is a 1, negative 2, 5 times 3, 4, 1. So this is a dot product. We know how to do it. So 1 times 3 plus 4 times negative 2 plus 5 times 1. Check, check, check. This is going to be 3 minus 8 plus 5. Gotcha, it's a 0. So therefore, we verify that AB, the vector perpendicular to CD. We verified. So you can think about this question as well. All right, so I'm talking about equation of a line, okay? And then from the observation between two vectors that are parallel line, we found out very interesting equation, vector equation, parametric equation, and symmetric equation. So with the given information, you can find out the specific point where, they're, intersect with the XY plane or other plane, or you can find out more points on that line, okay? So that was the practice example 1, 2, 3, 4. Now I'm gonna keep developing that idea. So in the slide, let's talk about the distance, okay? Between point and line, okay? So let's say you have the plane, okay? We have a plane parallelogram. This is the parallelogram. It looks like a parallelogram, so there is no, every lines are equal. It's a parallel line. And I have a vector right there. Okay, this is another vector here. I want to find out. So let's say you have a very far, you have one of the point on the parallelogram. Let's say this is M. This is a point. And then this is the line. This is the equation of the line. Equation of a line. We don't know what that is, but there's a vector, right? I want to find out the distance. I want to find out the shortest distance between the point and line. The shortest one, so this is actually shortest, because this is going to use in the physics concept a lot. But anyway, since this is the parallel line is actually leaning to, parallel line is not a straight line. What I'm saying is you have a parallel line here, and this is the vector. This is not the true, like the shortest line between this point to the line, this point to the line. If you want to find out the shortest line between point and line, this is the shortest line, the vertical, exactly the vertical creating the 90 degree. So to find out that, we're going to do a little bit of math. So I'm going to draw here. So this is actually better. We need to find out a perpendicular relationship between a point and a line, right? Perpendicular, when you create this parallel line does not create the perpendicular line. When you have a perpendicular line, whatever the line that is perpendicular to the line, that's the shortest one between two, right? So that's the image. So we assume that the M, there's a line that is a perpendicular, there is a point M that is a perpendicular to the line L. So if you look at this image, I'm going to make a little bit of triangle here. So let's just say we have a triangle. So let's say this is the point P. So this vector, if you do it, it's going to be PM vector. And then this is the D that I'm looking for. So let's say there's no P. So this is the point that distance that I'm looking for. So according to SOHCAHTOA, sine theta is so opposite over hypotenuse, correct? So what is the opposite? We have an angle here. So this is the opposite, which is a D over hypotenuse. That is going to be PM vector, and the length that's going to give you the distance, magnitude. I'm going to do the cross multiplication. So from here, we have a sine theta, D over length, PM. So that means if you do the cross multiplication, D is equal to sine theta times the magnitude PM vector. Are we okay so far? And then here, a little bit of proof stuff. And here we're going to recall. We know that PM times, if you multiply whatever two vectors, magnitude, we learned in the previous chapter, each magnitude vector, right, times sine theta. So this is the recall we learned in the previous unit. So therefore, we can think about it. We can think about what is that? PM. So here, so in this equation, we can solve for PM. PM vector magnitude is equal to whatever the remaining move to the other side. So PM vector times the V vector divided by V vector times the sine theta. So now what happened is we just solve for what the PM is this. So I'm going to plugging in this one into the PM spot. Am I correct? So we're going to use that modification. So now D equal to sine theta. Yes. And then if you feel like this is a complicated function, let me just rewrite it a little bit. Let's do a little bit of modification. Oopsie, oopsie, oopsie. So instead of solve for PM, actually solve for sine theta will be better because I'm going to cancel something. Sorry about that. So let me go back a little bit, back. So here, instead of solve for PM, let's solve for sine theta. So what I'm saying is solve for sine theta will be, right, PM magnitude V vector, and you're going to divide it by this, each magnitude. Right? So now, actually, we're going to plugging in this one. That is a sine theta. We're going to plugging in this one into sine theta. That's better. Because I see the cancellation PM. That's why. So therefore, we can say D equal to sine theta is now PM times the V vector over each magnitude times PM. So I can see the cancellation, PM. That's actually what I was going to do. So what is the remaining stuff? We found out PM times the V vector over V vector. So this is the formula we just found out. So the distance between, this is the distance between a point and a line, okay, should be a perpendicular. Thus, the formula D we just found out is going to be PM times V vector over divided by V vector. That's what we just found out. So you don't need to worry about this proof stuff. Actually, the textbook already gave you the formula. We're going to actually use them, but I just wanted to show you where and how we got this formula. Okay? So let's take a look at the example. We're going to utilize this to find out the distance between point and the vector and the line. Okay? So let's take a look at example to solve for the distance. Here we go. So you see that in this question, find the distance between point and line. In this time, this line is a symmetric equation form. So this is symmetric equation. So we believe that this equation is going to be like line. And then we have a point M, 1, 1, 3. They want to find out this distance, right? The shortest distance. So there should be perpendicular relationship. So from the symmetric equation, excuse me, the symmetric equation said x minus x0 over a, y minus y0 over b, right? We're just writing the symmetric equation, z minus z0 over c. So we see that here, x0, y0, z0, it is the same as, I can see that, -3, because negative is a default. We have actually +3. Negative is a default. So 3, -1, and positive 3. So this is x is 0, y is 0, z 0. That's the point on the line. So there's a point, let's say P, 3, negative 1, and 3. So let me write down all the information from the what? Symmetric equation of a line. We can find vector, which is the bottom, ABC, correct? Vector ABC, which is 4, 2, invisible, negative 1, correct? And then this is also a direction vector we can call. Okay, and we also find out the point. We can find out, we can find a point on a line, on the line. Let's say that is a P, 3, negative, 3, correct? So that's all we found out. So you can find out x is 0, y is 0, z is 0. That's a point on the line. And then you also find out the direction vector, right? The direction vector on the line ABC. So that's something given by looking at the symmetric equation. We found out the V, ABC, 4, 2, 1, and point 3, negative 1, and 3. So now what happened? We are looking for the distance, right? At the end, we're going to use a formula. So now let's find out the vector PM. So we have M and P is a given. Let's find out this vector, right? So first, we're going to find out the PM vector. So that is going to be, PM is a given now. So 3 minus or 1 minus, the order does not matter. So 1 minus 3, comma, 1 minus minus 1, comma, 3 minus 3. So which is negative 2, 2, 0. This is a PM. Because according to the distance formula, you're going to have a PM vector times the V vector divided by the V vector. Right? So we're going to do this work. Okay? So we know what the V, which is ABC 4 to 1. So let me make a space. So here, let's do PM vector times the V vector. So this is the cross product, if you remember. So we're going to have a, what happened? Matrix. You have I, J, K. PM vector, we just found out negative 2, 2, 0. And V vector, we found out 4, 2, 1. By using the determinant, we can find out the, the cross multiplication. So let's do it. You have a 2, 0, 2, 1. And minus a J, you have a negative 2, 0, 4, 1. Plus K, negative 2, 2, 4, 2. So you're going to do all the cross multiplication. 2 minus 0, J, negative 2 minus 0, K, negative 4 minus 8. So basically we have a 2I plus double negative change of positive 2J minus 12K. So what happened? PM vector times the V vector, that cross, the cross product is going to be 2 to negative 12. Beautiful. So that's what we just talked about, the highlight, the numerator part. So we found out this, but now we are looking for the magnitude PM times V. That would be 4 plus, you're going to square 144. So it is going to be radical 152. And then the distance formula, we need to find out the bottom vector. So V, copy. So finally, the bottom one, in this time, we are looking for the V vector, right? So the V vector magnitude. So what is a V vector? V is here, right there, 4 to 1. So V vector is a 4 to 1. So magnitude V 16 plus 4 plus 1, which is a radical 21. So therefore, D will be radical 152 over radical 21. You can convert it to the decimal. So this is the distance. We just proved that this is, one more time, D is the distance between a point M and a line, let's say that is L, that they are perpendicular to each other. Okay, so that's what we just found out, the distance. So that's how you're gonna find out the shortest distance between the point and a line. Okay, so I show you all the work, how to solve this kind of question. You can definitely do all similar question like that. All right, a little bit of taking breath. I hope everything is going well so far. How are you guys? Everything is so far so good. All right, you can always pause the video. So that's one of the great thing when you are watching the video. So let's do the next example, but I'm not gonna do it. It's the same question, same solution. You can try and think about where this formula came from, and then try this. Try yourself. So we have a point. In this time, I'm giving you the parametric equation. So same thing, you can find out the point x0, y0, z0, and you can find out the v vector a, b, c from the parametric equation. Then find out the distance PQ times v vector's magnitude divided by the magnitude of the v vector. So same story. As long as you know what the one of the point and the vector direction vector, this is a direction vector. This is a point on the line. You can find out the rest of the information. It's a very similar what we just did it. So try this. I'm gonna do one more example. Let's keep going slowly and surely, okay? So another concept in 2.5, we've been talking about the line relationship, whether it's a parallel line or the distance between point and line. So let's talk about more. What kind of relationship you can find more, right? You can find further. So the relationship between line, it's so true. You can find out the intersecting relationship. So if you have two lines, they could be intersect, right? Or you can find out the perpendicular, exactly perpendicular, creating 90. And then you can find out parallel line, or you can find out nothing, neither relationship, but we are looking at this one in three-dimensional space. For example, line AD and DE. Where's the DE? These two is intersect at the point D. So we call these two lines. So this is a three-dimensional space. So you can find out like AD and DE. This is the just intersecting. And also you can find out AB and BG. They're exactly 90 degree, or this is also 90 degree, intersect and perpendicular both. So there's a perpendicular relationship, intersecting relationship. And also you can find out the parallel line where AB and CD, or AB and these two lines. There are so many parallel lines you can find out. And what is a skew line? Nothing. So for example, DE here, and then GF. They're not gonna really intersect, because they're keep going. They're going behind. They're going front. They're never gonna intersect. They never parallel line or perpendicular. So in that case, we call that as a skew line. So there are four different type of relationship in terms of the line. So check this information. And then the question is this. I'm gonna give you guys a couple, like it could be parallel equation, vector equation. I'm giving you guys equation. You're gonna define whether the two equation is a parallel line, perpendicular, or nothing, okay? So let's take a look at that example. So I have a two equation, parametric equation. So this is the one line, L1, and then these are the parametric equation. And I have another line, L2. and then they have a parametric equation in this form. I want to know whether they are parallel line, intersecting, or skew, or perpendicular. So all you need to do is find out the scalar, or find out the orthogonal relationship. So let's step-by-step work. So first, let's find the direction vector of L1 and L2. So according to the parametric equation, if you all the way go up, parametric equation has x equal to x0 plus at, y equal to y0 plus bt, z equal to z0 plus ct. So you know where's ABC, that's the direction vector. So you can find out ABC from each different line, right? So that is going to be, so L1, so V1 in L1, you can find out this is the A invisible 1, 4. So 2, 1, 4, this is the direct vector V1. And you can find out V2 in the second line, which is invisible 1. And then you can change that order, 1, 2, 3 in front of the coefficient. So there's going to be 1, 2, 3. So you can find out the direct vector. So now I want to see whether they are parallel line or whatever. They're parallel line? No, there's no scalar. There's no scalar. So we can find out the scalar. So this is not parallel line to each other. So this is going to be either perpendicular, intersect, whatever, skew. So let's talk about that. So we just found out it's not parallel line. So we're going to do some mathematical work. Step 1, I do know the first equation, they are same x. So x equal to 1 plus 2t, x equal to also s. So we can say 1 plus 2t equal to s, right? And then I'm going to solve for t. And then 1 plus 2t is s. So hold up there. What are you guys going to do? You can, plugging in 1 plus 4t equal to, so what I'm saying is, I'm going to just make a little bit better work. So I'm going to just get rid of it. So that's also same. And then in the second relationship, y is a t, and then y is a 2s minus 2, z equal to 1 plus 4t, z equal to 3s minus 2. So we're going to approach more algebraic way. And then what happened is, so these are same. So here we can say 1 plus 2t equal to s, or you can say t equal to 2s minus 2, or you can say 1 plus 4t equal to 3s minus 2. So you have a 3 possibility, that are corresponding to each other. So now I'm going to do a little bit of math work. Let's say the first one, I'm going to use the first one. So okay, so we have s, since s equal to 1 plus 2t, you can plug in s information, right, into here and here, right? So let's say we can, so now you have a 2 variable, and then I can condense it to 1 variable in terms of t. So sub into t equal to 2s minus 2. Are you following? So t equal to 2 times 1 plus 2t, that's s minus 2. So what happened? You can solve for t. So let me here. So therefore, I'm going to get rid of it. So now t equal to 2 plus 4t minus 2. And then we have cancel. So basically 0 equal to 3t. So 0 is a t. So what does it mean? T equal to 0, somehow they're going to be all equivalent. Okay, so then we're going to plugging in 0, then sub t equal to 0 into other equation. Just play, let's see what happened. I'm going to plugging in t into here now, so I can solve for s. So I can solve for s. So we're going to plugging in 1 plus 2 times 0 is s. So basically s is going to be 1. So we found out s is 1, t equal to 0, and you can find out other variable if you whatever you want. So now you can plugging in into one of the equation. Since we know t equal to 0, s equal to 1, now you can solve for, we can solve for x, y, z. Does it make sense? That's actually what I'm looking for. So what is x, y, z? X, y, z is going to be, I'm going to plugging in, x is going to be 1 plus 2 times 0, 1. Y is a 0, z equal to 1. So it is going to be 1, 0, 1. So what does it mean? Those are two lines. The two lines L1 and L2 intersect at 1, 0, 1. We just proved that. That's how you're going to do it. So I'm going to show you all the work. Just a little bit, minimize it. So in this question, I want to know whether they're parallel line, intersect, or skew. First of all, we check that they're not parallel line because there's no scalar that gives you the equal relationship between two lines. So I just solve for each s and t and x, y, z, because whatever you're going to solve for x, y, z, that's the point where those two, lines are going to intersect. Okay, so therefore we solve for s and t, and you found out the x, y, z. This is the point where two lines are intersect to each other. Okay, so you can think about more information. So this is a very thinking question, and you can think about more whether it is a parallel line. So you can find out 2 points in each line and then convert it to the vector and then multiply to each other whether it is a 0. So we prove that this is intersect two line. You can think more. Find the vector in each L1 and L2, right? So you can find out whatever the points on L1 and L2, you can find out 2 points, or find 2 points in each and L1 and 2. Let's say you have A, B points in L1, and you have a C and D points in L2. So find out the vector and check, multiply them is 0 or not. So you can also prove it is a not only intersect, but also perpendicular information. So this is something you can think about further. I will leave it for you. Okay, so this is how you're checking parallel line, perpendicular, or intersecting. And here is more practice if you want. So same question, you can see that. You can find out all the same practice, and you can find out the solution in our 2.5 textbook quiz. So this is one of the quiz questions. All right, so I'm almost done. Hang in there. So 2.5 is a little bit of long chapter. So let's go to one last concept. So the last concept is equation, not of the line, equation for a plane. Okay. So if you have a 3 points in the three-dimensional space, they're going to create a line, right? It does not mean that they're going to create a plane. I want to find out the plane in the three-dimensional space. So what is a requirement? Do you need a 3 points? Do you need a 4 point? No, if you have any 3 points that are on the same line, it's not going to be the plane. You need a point that is a little bit further, from other 2 points, especially here. You have a 2 points, and then one of the points on the line that is a perpendicular vector. You can always find out the vector. You can always find out the plane. So that's the keyword. So one more time, To find out the plane in three-dimensional space, you're gonna find out the vector that create the perpendicular between 2 points, and this vector, we call this is a normal vector, that is an orthogonal vector. Then always you can find out the plane. Okay, so for example, think about it. If you have this 2 and 1 is here, and then exactly this is the perpendicular, what happened? This is going to be creating the plane. We just proved that this is a plane. 3 points on the line does not mean that it's a plane. It could be just a line. But if you think about this three-dimensional space with the 2 points with the perpendicular point, always you're going to create the plane. So that's what the mathematical theory we can assume. So therefore, as long as you have a normal vector, which is the orthogonal vector, and then times the PQ line is 0, which means you have the equation of a plane. Does it make sense to you? So one more time, you have n vector, normal vector, times the PQ. We know that if it is a 0, that's orthogonal. And then we call that equation is the equation of a plane. So n, let's say vector ABC. And then PQ, we have x is 0, y is 0, z is 0, x, y, z. So you're going to find out the vector form PQ. And then you're going to multiply to each other. This is a dot product. So this is the equation of the plane. Okay, so nothing is special. So I'm going to bring that theory. So this theory is here. Given a point P and the vector n, the set of all point Q satisfying the equation n times PQ 0 because they're perpendicular relationship, this is going to be create the vector equation of the plane, which is we just found out, we just proved it. So this is we're going to use to find out the vector equation of a plane. So let's take a look at the example. This is a standard form. So for example is always help us. Write the equation of a plane, not the equation of the line. This is not equal to the equation of the line. We're looking for the equation of the plane, and they're passing through those 3 points. And then let's find out that equation. So to write an equation of a plane, we must find a normal vector, which is a perpendicular for the plane. And then let's find out the 2 vectors. So we have a 3 vectors. So one is going to be PQ vector. So 0, -1, 2, -1, 1, -2, which is a -1, 1, and 3. And then another possibility is QR. It doesn't matter which one you're going to choose. I'm going to choose a QR vector. So that would be -1, -0, -1, -2, 0, -1. And then -1, -3, -1. I want to multiply them if they are equal to 0 or perpendicular to each other. Okay, so we need to verify PQ vector is a perpendicular QR vector. So that means we're going to PQ vector times a QR. This is cross product, right? So we're going to find out the normal vector. So this is orthogonal relationship to both. So if we do, and then this is we're going to call the normal vector. So therefore, this is going to be IJK. We have a -1, 1, 3, -1, -3, -1. So you can solve the outcome cross product. I 1, 3, -3, -1, J -1, 3, -1, -1, plus K 1, 3, -3, -1. So calculate it. I cross multiplication, you should get 8. And then J, you should get positive -3. This is a -4 plus a 4K. So what happened? 8, -4, 4. This is a normal vector. This is a normal vector n. We found out. So we found out the normal vector that is a perpendicular to the points P, Q, or QR, okay? So now I'm gonna plugging into the equation of this plane. So I'm gonna copy that. That is going to be equation of a plane A, x minus x0, B, y minus y0, C, z minus z0 equal to 0. Plugging in everything, A. This is your ABC. We found out the vector A. And then you can plugging in x0, y0, z0. You can plugging in one of the point, doesn't matter. These are points. So I'm going to use a 1, 1, negative 2. So x minus 1, minus 4. Y minus 1, 4z minus z plus 2 equal to 0. And you can expand everything. It should be 8x minus 4y plus 4z plus 4 equal to 0. This is the equation of a plane we just got. Okay, so that's the example. You can think about it. Are you guys okay with that? So definitely you can do this, right? Nothing is, complicated. You look at the concept, what we are looking for equation for plane, not the line. So we need a normal vector. We don't know this information. You need to find out that. So if you found out the normal vector and then multiply with the vector between 2 points and then check it out if it is a 0, then plugging into the equation of the plane, that's what you're going to find out the equation for plane. So we got that concept. We found out the vector. To find out the normal vector, multiply them. And then we check the normal vector, and we check the points. So you can plugging in to find out the equation of the plane. Okay. So I hope this is getting better. Almost done. Hang in there. I'm sorry. It might be a little bit long video. So I think you can try this one. Same question. So this is the same practice. I'm going to do this one. Okay. Let's find the point with the line with the parametric equation. So whoa. I think I have, yeah, this is the same question. So let's do this one. I do have, yeah, plane through the point 2, 4, negative 1. Normal vector is a given. So find the intercept. So the equation of the plane. We know A, x minus x0, B, y minus y0, C, z minus z0. And then point is a given, x0, y0, z0. Normal vector is a given, a, b, c. So we can plugging in, which is 2x minus 2 plus 3, y minus 4, 4, z minus minus 1 equal to 0. Again, I can do all the distributive property. 2x minus 4, 3 minus 12, 4z minus minus plus 4 equal to 0. So we have a 2x plus 3y plus 4z equal to 12. This is the equation of the plane so far. I want to find out the intercept. I want to find out the intercept, in this plane. So to find out the intercept, we know x-intercept where y, z equal to 0. Y-intercept exists where x and z equal to 0. Z-intercept is where x, y equal to 0. So therefore, you're going to plugging in to find out the x-intercept, y, z, 0. So x equal to 6. This is going to be y equal to 4. The last one is z equal to 3. So what does it mean? 6, 0, 0, 0, 4, 0, 0, 0, 3. So in this plane, you have x, y, z. So 0, 4, 0. So let's say this is x, y, z, 6. And then you have 4, you have a 3. These are the intercept point. So the plane is passing through those 3 points. Something like this plane, triangle. This is the only way you have a 3 all intercept. Intercept means you're exactly passing through the x-axis, y-axis, and z-axis. So we have a 3 intercept. So this plane, when you draw the image in 3-dimensional space, they're going to passing through this, looks like a triangle plane. So you can think about this practice as well. All right, let's do more because 2.5 is a challenging topic, definitely. So I'm gonna give you guys a more practice. Let's go to example 12. So one of example, find the point at which the line with the parametric equation is given. Parametric equation is a given and it is an intercept with the plane. I wanna know when, okay? So we have a, parametric equation and then, the plane, and then there is a parametric equation, looks like a line. There's an intersected point. I want to know when, right? So to find out more information, you can say the line equation and equal to plane equation. When they're equal to each other, you can find out the intersect exactly when they're meeting each other. So therefore, we can solve for x. We're gonna sub to find out the line equation. We're gonna sub the parametric equation of the line into the plane equation. Does it make sense? So therefore, if you do that, x, y, z is a given. So 4 times x is a given. 5 times negative 4t plus minus 2, 5 plus t. That is equal to 18. So we're going to do all the distributive property. A plus 2t minus 20t minus 10 minus 2t equal to 18. So you're going to solve for t. So negative 10t equal to 20. When t equal to negative 2, they're going to be intersect to each other. So one is a plane, another one is a line. When t equal to negative 2, they're going to be intersect at the moment. Okay, so you can think a variety of cases in terms of plane and line. So I'm giving you guys all the formula and equation and where it came from, the backgrounds, so you can think about it, okay? All right, hang in there, almost one last concept, the last concept. So far we talk about, I'm just going back to here. So far, not here, I'm gonna make a space after here. So if you remember, we talk about line, there's a 3 equation. We also talk about the plane, right? There's an equation. Sometimes they're going to be intersect to each other. So you can think about when they're going to be intersect in more cases, practice. What we're gonna do here, the last case, what if you have a 2 plane? Okay, not just line. Line, we talk about parallel, perpendicular, or skewed, or neither. Same thing, plane. You can have a 2 parallel line plane, or you can have intersect plane. So we're gonna talk about that case, but in this time, we're gonna focus on parallel line case. So we are talking about parallel and intersecting planes, usually 2 planes. Okay, so the last scenario. So 2 planes, if it is a parallel line, okay, that means their normal vectors are also parallel lines. So think about it. I have a plane here, right? And this is your normal vector, n1, correct? We talk about it, 90 degree. And I have another plane that is a perpendicular, that is a parallel line with the first plane, and the normal vector is here. This is n2. What do you guys think? This 2 normal vector is also parallel line. You see that? So this is a true sentence. If 2 planes are parallel line, then their normal vectors are also parallel line. So true visually. Okay. So if two planes are not parallel, then the intersect in a straight line, or they're not going to be, in other words, this normal vector are not parallel line. Okay, so let's take a look at the example. Exactly where two planes are not parallel line. So we're going to find out. First of all, from the equation, of two plane, we can find normal vectors n1 and n2. Am I correct? So here in this equation, you can find out the normal vector. This is a plane 1. This is a plane 2. So according to the plane equation, you have n1 vector, normal vector for -2 and 1. That's what the equation meaning. And 2 normal vector, we have 2, the coefficient. They are the normal vector. And as you see that, n1 and n2 are not parallel line. Are you sure? I'm not sure. Is it parallel line or perpendicular line? We don't know. So we're going to check. Okay. First, n1 times n2 is a 0. If it is a 0, it is a perpendicular. If not, maybe they're going to be the parallel line. So let's check. So for -2, 1, that product, so it is going to be 8 minus 2 minus 4. What are you going to get? It's a 2, which is a not 0, so not perpendicular. Okay? Which means this is not perpendicular. They're not also parallel line because I don't see the scalar. No scalar. And then no perpendicular. Right? So they're going to be just intersect. So it means n1 and n2 intersect to each other. And then they're going to create with creating an acute angle. They're going to be intersect. So the two plane, they're going to be intersect. And then this is the normal vector. This is their normal vector. They're going to, if you meet, create a small angle. I want to find out the angle. So therefore, if you remember, to find out the angle between two vector, we use a cosine theta and 1 vector times n2. This is a 2.1 concept. We talked about it. Magnitude h1. So this is a very important formula we learned. And then let's find out that one. So what happened? We have n1 vector times n2 vector. We just found out which is a 2. And then each magnitude, so this is the magnitude, 16 plus 4 plus 1 times 4 plus 1 plus 16. If you calculate it, radical 21 times radical 21. So we got cosine theta 2 over radical 21 times 21. I want to find out the angle that they're creating. So what happened? Theta will be cosine inverse. That's it. 2 over 21. And then you can convert it. This is a radian. You can multiply, like 180 over pi. So you can find out the degree. Exactly, you should get 84.5 degree. So this is the angle that the two planes are intersect, and the angle between two normal vector. They're going to be intersect. It's not perpendicular. It's not 90 degree, because we failed to prove that they're orthogonal, but it's going to be intersect, creating only 84.5 degree. So this is the case where you can find out two planes are perpendicular or a parallel line. Parallel line is so simple because you're going to find out the scalar between two normal vectors. But in this time, we didn't find out. So we also check it is not even perpendicular. They are just, intersect, creating 84.5. That's it. Okay, so same question, you can practice. Try this 3. Same question, nothing is special. You're going to define all the normal vector and check their relationship, whether parallel line or orthogonal. Okay, so you can find out the solution as well in our practice textbook. Okay, last one, almost, I'm not going to really spend too long time. So also you can find out the distance between, point and line. Okay, so the formula is given. So this is not going to be used a lot, but I'm just showing you. So if you have a point and you have a plane equation, the distance between, plane and a line, so there's a line, you can find out the distance. And then this is the formula. So you can simply calculate this one. So I'm looking for the distance between point and plane. So if you go up over, we talk about the point and line. So there's a 2 case. Distance between point and a line. Distance between a point and a plane. So that's the different scenario, right? Point and a line, point, plane. We are talking about the second case. So I introduced both anyway, so you can think about it. So let's take a look at this question quickly. According to the formula, A is a given, so you can find out the A. So from here, right, you can find out for -6, 1, this is a normal vector, that's ABC. And you have a point, x is 0, y is 0, z is 0. So 8 times 4 times 3, plus -6 times -2, 1 times 7, absolute value divided by the magnitude of the A vector, 16, 36 plus 1. So if we do it, 26 over, right, equal 53. So this is the distance between distance between a point and plane. So you should read the question carefully. Whether we are looking for point and a line or point and a plane. Okay, so we have a point and a plane, right? And then the previous one, point and a line. That's a different thing. Okay, so you can practice one more example. I'm giving you, the points, you can find out that information. So try this one as well. So you can try first as yourself, and then whenever you have questions, you can post it in our discussion board and we can talk more. But here, we talk a lot, 2.5, it's a pretty long topic. I'm gonna summarize it. In 2.5, we talk about how to write vector, parametric, and symmetric equation of a line, okay? When you have a given 2 points. And also we talk about how to find out the distance from a line to a point. And also we talk about how to write the vector, how to write the equation of a plane, right? And then we also find out the distance between a point and plane, okay? So there are many characteristics between plane, lines, and vector. Think about it. And then you can also find out the angle between 2 planes, which is this example, which is a very, very, very popular example. Okay, so that's all about it. So if you go all the way up, I'm sorry, here, this object, we learn pretty much everything. I show you each example and we practice all together. So whenever you have a question, okay, feel free to post in our discussion board. And then now you can solve quiz 2.5. There are more embedded video, and please read textbook. This is also important. There you can find out more information. So anyway, I extract all the given important information so far. I will see you guys in the next video. Thank you, everyone. See you soon. Bye-bye.